Good evening, children.
Good evening,
Good
ma'am.
evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening, ma'am.
Hi, good evening. Yeah. So last class we stopped here. We understood how to find the zeros of a quadratic polynomial. And after finding the zeros, we understood how to verify the relationship between the zeros and the coefficients. Finding the zeros of a quadratic polynomial using, sorry children, a student is calling, just a minute. Yeah, so I was telling you that you've learned how to find the zeros of a polynomial. So how to find the zeros depends on the quadratic equation given to you. If it has all the three terms, the x square term, the x term, and the constant, then you factorize by splitting the middle term. If it has only the first two terms, that is the x square and the x term, the x square term and the x term, or the y square term and the y term, then you will have to take out x or y common and factorize. If it has only the square term and the constant, then we factorize by using the identity a square minus b square. A square minus b square. That's what we saw in the last class. So there are, three different ways of factorizing a quadratic equation depending on which terms are given. So if all the three terms, I'm repeating, if all the three terms are present, the x square term, the x term, and the constant, if all the three terms are present in the equation, it's called a pure quadratic equation. This is a pure quadratic equation, okay, where you have all the three terms, the x square term, the x term, and the constant. In this case, we factorize by splitting the middle term. And the two solutions or two roots are alpha and beta. Sometimes we have only the x square term and the x term. We don't have the constant is equal to 0. In this case, we factorize by taking out x common, x into x, something like this, okay? And the product is 0. So we equate each of it to 0 to find the zeros. The third case is when you have the x square term and the constant. The x square term and the constant. So here we use the identity a squared minus b squared to factorize. A plus b into a minus b are the two factors. Okay, you'll have only the, so supposing you have x squared minus something like 7 is equal to 0. Okay, so then we say x the whole square minus root 7 the whole square is equal to 0. Minus root 7 the whole square is equal to 0. So we treat it as a difference of two squares, a square minus b square, which is a plus b into a minus b. So x plus root 7 into x minus root 7. So you must remember how to factorize, and then you'll have to equate it to 0. You'll have to equate each factor. So x plus root 7 is equal to 0. So x is equal to minus root 7. Similarly, x minus root 7 is equal to 0. X is equal to plus root 7. So these are the two zeros, alpha and beta. So, so to find the values of alpha and beta, you'll have to factorize the given quadratic equation. The two zeros which you get will be alpha and beta, are taken as alpha and beta. And the coefficients, to find the values of alpha and beta, we need to factorize. And the coefficients are already there in the quadratic equation. The values of A, B, C are already there in the quadratic equation. You can compare the given quadratic equation to the standard form and get the values of A, B, C. For that, you don't have to work anything for that. It's all there. In the given quadratic equation, from the given quadratic equation, you can find the values of A, B, C. Now, using these, you will verify the relationship between the zeros and the coefficient. This is what we saw in the last class. Now, we also need to know how to construct a quadratic equation or a quadratic polynomial. Okay, to construct a quadratic polynomial. If you equate it to 0, it's a quadratic equation. So no big deal. A polynomial, when you equate the polynomial to 0, it's a quadratic equation. Now, how do you construct? How do you construct the quadratic equation or the quadratic polynomial? So you can see here in the last class, okay, now see here, what is the quadratic equation here? X square minus sum of the zeros, right? X square minus sum of the zeros. So let's call it S, sum of the zeros, into X plus the product of the zeros. You can see it. You can see it here. See this one. This is how we construct the quadratic polynomial when the zeros are given. When the zeros are given, or when the sum and the product of the zeros are given. I'll make it more clear. Just look at this one. Just look at this. Okay, x squared minus alpha plus b minus x squared minus alpha plus beta of x plus alpha beta is equal to 0. See, but the standard form is this one, ax squared plus bx, not minus bx. The standard form is ax squared plus bx plus c is equal to 0. To construct a quadratic polynomial, you can see here, it is x squared minus alpha plus beta of x plus alpha beta. So now, to construct a quadratic polynomial when the zeros are given, okay, when the zeros are given. To construct the quadratic polynomial when the zeros are given. See, when the polynomial is given, you can factorize and find the zeros. When the zeros are given, you can construct the polynomial, just the other way around. When the quadratic polynomial is given to you, you can factorize and find the zeros. Now the zeros are given to you. You have to use the zeros and construct the quadratic polynomial. So the reverse process. So to construct, how do you construct a quadratic polynomial when the zeros are given? What are the zeros? Alpha and beta. Alpha and beta. So there are two ways. Okay, so that means you're given alpha and beta. You're given alpha and beta. Zeros meaning you're given alpha and beta. Okay, you're given alpha and beta. So how do you construct? One is the required quadratic polynomial. Okay, required quadratic polynomial is equal to x minus alpha into x minus beta. We have understood this already. When you know the zeros, you can find the corresponding factors. If 5 is a 0, x minus 5 is a factor. If minus 7 is a 0, then x plus 7 is a factor. Change the sign. If 5 is a 0, then x minus 5 is a factor. Plus 5, minus 5. If minus 7 is a 0, minus 7 plus 7, x plus 7 is a factor. Similarly, if alpha and beta are the zeros, then x minus alpha, because plus alpha plus beta. So x minus alpha and x minus beta are the factors. The product of the two factors will give you the quadratic polynomial. X minus alpha into x minus beta. X minus alpha into x minus beta. So supposing the zeros are 7 and like what I just told you, minus 7 and 5, the product x plus 7 into x minus 5. When you do this, when you find this product, you will get the quadratic polynomial. If you equate it to 0, that's the quadratic equation. So this is one of the ways of finding the quadratic polynomial. The other method is what we just saw. required quadratic polynomial is equal to x squared minus alpha plus beta. So that means that whatever, so I don't remember what I wrote. So I think 7 and minus 5. Okay. Alpha plus beta of x. You know the values of alpha and beta. That's what is given to you. So just substitute those values here. X squared minus alpha plus beta of x plus alpha beta is the required quadratic polynomial. Somebody's mic is enabled. Please disable your mic. So the required quadratic polynomial is x squared. See here when the first cases, meaning the first method is when alpha and beta is given, x minus alpha into x minus beta. The product will give you the quadratic polynomial. In the second one, we have a standard version, x squared minus alpha plus beta. So put the values of alpha and beta into x plus product of the zeros. This is the required quadratic polynomial. You can also write it as x squared minus sum of the zeros into x plus product. Sum of the zeros into x plus product. Okay. Now, so sometimes you're given the zeros and you're asked to construct the quadratic polynomial. Okay. Sometimes you're given the sum of the zeros and the product of the zeros. Okay. You should be very careful. It's very simple, but you need to be careful while reading the question. So to construct a quadratic polynomial when the sum of the zeros, the zeros are not given, the sum of the zeros is given to you. You don't know the zeros. See, if the sum of the zeros is 6, the zeros can be 1 and 5. To get the sum of 6, you can have so many pairs of numbers. So you don't know the zeros, but you know the sum of the zeros. 1 second, children. Yes, children, thank you so much. So now to construct a quadratic polynomial when the sum of the zeros and the product of the zeros and the product of the zeros are given. So the zeros are not given. The sum of the zeros and the product of the zeros are given. Okay, so in that case, you can use this directly. Required quadratic polynomial is equal to x squared minus alpha plus beta of x plus alpha beta. Here you should be careful. The given two numbers, now it will be given that the sum of the zeros, that is alpha plus beta itself is 7. And the product of the zeros meaning the product itself is say like 10. So that means you should say alpha plus beta, this entire thing is 7. And alpha beta, this one is 10. By mistake, you should not write 7 plus 10 here. Alpha is 7 and beta is 10. Alpha plus beta is 7. Alpha beta itself is 10. Alpha and beta is not given to you. So you should just be careful. It's a very simple thing, but you just need to be careful. So you should see what is given. If alpha and beta are given, or alpha plus beta and alpha beta, that is the sum of the zeros and the product of the zeros are given. Either the zeros are given, alpha and beta, or the sum of the zeros and the product of the zeros are given. So for both, you can use this. Whether the zeros are given or the sum and product of the zeros are given, for both you can use this one. If the zeros are given, substitute the zeros here. If the sum is given, for the whole thing, substitute the sum. And for this whole thing, the product. So this one is when anything is given. This is when anything is given. That is, whether some product or the zeros are given, you can use this one. This you use when alpha and beta is given to you. That is, the zeros are given to you. When the zeros are given to you. Is it fine, children?
Yes, ma'am.
Yeah, please make a note of this. Quickly make a note of this.
Completed, ma'am.
Okay. Done, children? All of you?
Completed, ma'am. Completed, ma'am.
Okay. All right. Yeah. Now we'll take up some questions. Write down along with me. Okay. Ready, children? Listen to me. I'll give you time to write. Please listen to me. First, take up the given quadratic polynomial. What is given to you? F of x is equal to x square minus 6x plus k. Okay, so you're given a quadratic polynomial. Now, first from this, what more information can you get? You can find the sum of the zeros. You can find the sum of the zeros because it's given there. See here, alpha and beta are the zeros of this polynomial f of x. So what is alpha plus beta? Minus b by a. If you want, you can also write the values of a, b, and c. Okay. So on comparing with ax square plus bx plus c, what do you get? We get, what's the value of a? What's the value of a?
K.
1, ma'am.
What's
1.
What's the
One.
value of b?
Minus 6.
-6.
Minus 6.
And what's the value of c?
K.
K. Very good. Now what is alpha plus beta given by?
Minus 6.
No. It's given by what?
Minus C by A.
Minus B by
Minus
A.
b by a. Minus b by a. So that is equal to minus
Minus 6.
b. Minus b. See, minus, this is b in the bracket. In the bracket, what I've written is b. Minus is here. B is here. By a. So that is 6. Then what is alpha beta?
C by A.
C by a. What is c? K. K by 1, which is k.
1.
So
K.
this is what you should always do. Very good, very good. Okay, so when you're given a quadratic polynomial, you must first find the sum of the zeros, which is given by minus b by a, and the product of the zeros, which is given by c by a. We need to use this information now working ahead. So you should find this always. Now, what is the question? We have to find the value of k. And there's another condition or an information given to us that alpha square plus beta square is equal to 40. Now let's understand the question, children. Don't be in a hurry to work. Alpha and beta are given to be the zeros of f of x. Okay, f of x is a quadratic polynomial. Alpha and beta are the zeros. So from that, what can you find? Alpha plus beta and alpha beta using minus b by a and c by a. Okay, reading ahead, you should find the value of k. And for that, to find the value of k, they've given you some other information. Alpha square plus beta square is equal to 40. Alpha square plus beta square is equal to 40 is given to you. Okay, now see here. Please see here. Now, what is this you have? I'll do it in two ways. You have that alpha plus beta is equal to 6, right? Alpha plus beta is equal to 6. So see here, alpha plus beta is equal to 6. Now square this on both the sides. So alpha plus beta, the whole square is equal to 6 square. So alpha plus beta, the whole square is a square, alpha square plus 2ab. Or you can write alpha square plus beta square plus 2 alpha beta. A square plus b square plus 2ab is equal to 36. But in the question, we are given the value of alpha square plus beta square. How much is this?
40.
40 plus 2 into, what is alpha beta we found? What is alpha beta?
K.
K. See here, it's there. Alpha beta is K. Substitute.
Plus 2K. 2K.
Very good. Very good. Plus 2K is equal to 36. So 2K is equal to 36 minus 40.
Minus 40.
Very good. 2K is equal
K
to
is equal
minus
to
4. Minus 2. This
K
is one
is
way
equal
of
to
doing it.
minus 2.
Very good, very good. The other way of doing it is, it's given that alpha square plus beta square is equal to 40, right? Okay, you're given this. What is a square plus b square? It is a plus b the whole square minus 2ab. If you're very good with the identities, you can do this. Alpha a square plus b square is a plus b the whole square minus 2ab. See here, I'll tell you how we get that. I'll tell you how we get that. See here, what is a squared plus b squared plus 2ab equal to? It is a plus b the whole square.
Whole
A
square.
plus b the whole square. So from this, a square plus b square is equal to a plus b the whole square when you transpose minus 2ab. So you can remember this. A square plus b square on transposing, children. This is the identity which you know. A square plus b square plus 2ab is equal to a plus b the whole square. When you transpose this, a square plus b square is equal to a plus b the whole square minus 2ab. Correct, children? Yes or no, children?
Yes,
Understand?
Yes, ma'am.
All right. So now you can use this also. So what is a square plus b square? It is a plus b the whole square minus 2ab. So you can also start like this. You're given alpha square plus beta square is 40. But what is a square plus b square? It is a plus b the whole square minus 2ab. Alpha plus beta the whole square minus 2 alpha beta is equal to 40. See, instead of a square plus b square, you're writing a plus b the whole square minus 2ab is equal to 40. Now, what is alpha plus beta? We have it. What's alpha plus beta? 6. 6. So 6 square minus alpha beta is k. 2k is equal to 40. 36 minus 2k is equal to 40. Minus 2k is equal to 4. K is equal to
minus 4, ma'am.
Why minus 4?
Correct, ma'am. Correct.
Okay. So you can do it both the ways, children. Anyways, here we write alpha plus beta and we square it on both the sides. Otherwise, you can do it like this also. Take down, children. Take it down. When I'm explaining, you must stop writing and listen to me. Once you've understood, you should just copy it from the screen. Don't try to do it on your own. You might not present it correctly. Please copy it from the screen. Don't work by yourself. All the steps must be in your book. All students are requested to copy the answer from the screen.
Completed, ma'am.
All right.
I'm going to show the previous slide.
Sure. Yeah. Done, project?
Yes, ma'am.
Okay. Yeah, it's time. I'm going to clear the slide. Okay.
Ma'am, isn't it minus 4 root 3x?
Oh, yeah. Thank you. Yeah. Then what did I write? Plus 3, huh? Yeah.
Yes, ma'am.
All right. Very good. Yes, children. Now it's time to do together. Don't write. Listen to me. Now what is given? F of x is equal to x squared minus 4 root 3x plus 3. Now what's the first thing we'll have to do? Compare it with the standard form. So what are the values of a, b, and c? A is equal to
A is equal to 1, 1.
b,
B is equal to minus 4 root 3.
and c is
3.
Plus 3.
3, ma'am.
3. Now what is alpha plus beta? After finding a, b, c, find alpha plus
Ma'am,
beta.
minus b by a.
Yeah, that is minus
Minus of minus 4 root
yeah.
3.
This is minus, this is b by a. So it is 4 root 3, positive 4 root 3. And alpha beta is equal to c by a, which is 3 by 1 or 3. So this is the preparation. Okay. After this preparation, read the question ahead. Find the value of alpha plus beta minus alpha beta. See, you're given a quadratic polynomial. Its zeros are alpha and beta. Okay. Now you have to find the value of alpha plus beta minus alpha beta. So alpha plus beta minus alpha beta is equal to, what is alpha plus beta? 4 root 3.
4 root 3 minus 3.
Minus 3. That's all. This cannot be simplified further. That's all. This is the answer. Write down, children.
Ma'am, is it alpha minus beta is equal to 9 in the third question?
9. Yeah. Alpha minus beta is equal to 9.
Okay, ma'am.
9. Understood. Again, we need to find the value of k, children. So here we have another equation. See, so now we must have got used to this question. There is a quadrant. So normally there is a quadratic polynomial and it is given that alpha and beta are the zeros. There's a quadratic polynomial and it's given that alpha and beta are the zeros. So immediately what you do, you write out the values of a, b, c, and then you write out what is alpha plus beta and alpha beta. That's the preparation. Okay, whatever be the question, this is the preparation. Whatever more information you can get, you should write down all that. So this may be used for the further working. So we just prepare like this. Now, there is another information given in the question that alpha minus beta is 9. Find K. Again, this I would like to do it in two different ways. Please write down the question. All of you must be careful because the screen is small, so you can see this is the third question. I've started the answer here. There's a third question, there's a third answer. Write down the question, I have to clear the screen. The question alone I have to clear.
Completed, ma'am.
Yeah.
Completed, ma'am.
Okay. So we'll see two ways of getting the answer. So one is recommended is, using this identity, doing it in some new way is recommended. So now there is this identity which says alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. Let me tell you why. So let me take another slide. See here. Listen very carefully, children. Now tell me what is a plus b the whole square, children? What is this? Tell me.
A square.
Alpha square plus 2ab plus b square.
Okay. Now what is a minus b the whole square?
A
A
square.
square minus 2ab plus b square.
Now subtract the two equations. Subtract. Okay, so subtract. So that means you should change the signs here, right? Okay, or a plus b the whole square minus a minus b the whole square will be equal to a square plus 2ab plus b square minus a square minus 2ab plus b square. We'll have to subtract. So this is a plus b the whole square minus this is a minus b the whole square. So what do you get? A plus b the whole square minus a minus b the whole square is equal to a square plus 2ab plus b square minus a square plus 2ab minus b square. So a square minus a square plus b square minus b square. So we have a plus b the whole square minus a minus b the whole square is equal to 4ab. Very simple but very important identity. It'll it'll help you save time in many places. So please remember this. Now, what will you get when you add? Now, this is one identity. Okay. Now, what will you get when you add? What is a plus b the whole square plus a minus b the whole square? So a plus b the whole square is a square plus 2ab plus b square. And a minus b the whole square is a square minus 2ab plus b square. Now, when you add these two, so that will be equal to a square plus 2ab plus b square plus a square minus 2ab plus b square. So here plus 2ab minus 2ab gets cancelled. A square plus a square, 2a square. B square plus b square, 2b square. So here you can take out 2 common and write a square plus b square. So a plus b the whole square plus a minus b the whole square is equal to 2 of a square minus b square. Very, very important. These two identities are very important. It's used in many places, even in trigonometry. It helps you save time. Make a note of this, children. Very important. Make a note of this. This is not a part of the answer. Here we are seeing how these identities are derived. Make a note of this. Tell me once you're done. Done, children?
Yes, ma'am.
1 minute, ma'am.
Okay.
Completed.
Yeah. Can I clear the screen, children? Anybody still writing?
No, ma'am. No, ma'am.
Okay. So what are the two identities which we just learned? A plus B the
A
whole
plus
square.
B the whole square minus A minus B the whole square is equal to 4AB.
In terms of alpha plus beta the whole square. Yeah, tell me.
Alpha minus beta the whole square is equals 4 alpha beta.
Yeah, very good. What's the other one in terms of A and B? A plus B the whole square.
B the whole square plus A minus B the whole square is equal to 2 into A plus B the
Sorry.
square. 2 into A plus B the whole square.
2 of A square plus B square. 2A square plus 2B square, which is 2 of A square plus B square. So in terms of alpha beta,
Alpha plus beta the whole square plus alpha minus beta the whole square is equal to 2 into alpha square plus beta square.
yeah, very good. Now I'm going to use this identity. I'll tell you why we are going to use this identity. See here, that's what I've written here. Now we choose to use this identity because do we know the value of alpha plus beta? Yes. Do we know the value of alpha minus beta? Yes, it's given to us in the question. And do we know the value of alpha beta? That also we know. So since we know the values of the three expressions in this identity, it is appropriate to use this in this situation. Agree, children?
Yes, ma'am.
What is given? What is alpha minus beta given? I didn't note that. What is alpha minus
9,
beta?
ma'am. 9.
9. This is given. This is given. So since see the expressions, we know alpha plus beta, we know alpha beta, we know alpha minus beta. So we are trying to write an identity which connects these three expressions, which is alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. So now just substitute. This is 1 square minus this one is 9 square is equal to 4 into minus k. So 1 minus 81 is equal to minus 4k. Minus 80 is equal to minus 4k. So you get k is equal to 20. The value of k is 20. Yes, please take down this, children. I'm doing the alternate method. Please take down the first method. So the other way of doing it is solving the two equations, getting the values of alpha and beta. And since you have to find k, we know that alpha beta is minus k. It's there. It's all there. So substitute the values of alpha and beta and find k. It's easy to understand. Right on, children? Any questions, please feel free to ask. Whatever question you have in your mind, please get it clarified. That will be helpful for the others also.
Completed, ma'am.
Yeah.
Completed, ma'am.
So the second method, alpha plus beta is 1 and alpha beta is minus 9. So we solve the two equations and find the values of alpha and beta. Alpha and beta. Now the question is to find the value of k. So how do you find k? So see, this one we have not still used. We have used this one. We used this one and this one and solved the two equations to find the values of alpha and beta. We have not still used this information. Alpha beta is equal to minus k. So using that, you can find the value of k. Alpha beta is minus k. What is alpha? 5. What's beta? Minus 4. And that is minus k. So minus k is minus 20. Minus gets cancelled on both the sides. K is equal to 20. Any doubts, children?
No doubts, ma'am.
Okay, next one. Find the values of a and b if they are the zeros of this polynomial. So for this polynomial, earlier it was given that alpha and beta are the zeros. So here, see, every quadratic polynomial can have a maximum of 2 zeros. In general, they are called alpha and beta, but here they are called a and b. Find the values of a and b if a and b are the zeros. So instead of calling them alpha and beta, here they are called a and b. If a and b are the zeros of this polynomial. So what are a and b? The zeros. Normally alpha and beta, but here a and b are alpha and beta. Okay, so as usual, p of x is equal to x squared plus ax plus b. This is the quadratic polynomial. Children, now what is the sum of the zeros? What is sum of the zeros?
Minus b by a.
1 minute, 1 minute. Yeah, sum of the zeros is equal to minus b by a, correct? minus b by a. Now, I'll use a capital letter B and A because A and B is already used. A and B is already used. Or we'll write it in words. What is the sum of the zeros? Minus coefficient of
X by coefficient of x square.
coefficient of x squared. Why are we writing it like this? Because if we write minus b by a, no, that is already there in this question everywhere. So you can go wrong, like you'll mix up that. So let's write it in words, or you can use capital letter B and A. Or you can use minus b by a like this in capital letter so that you differentiate. Anything you can do. Okay, so sum of the zeros. What are the zeros? A plus b. Sum of the zeros is a plus b is equal to minus, what's the coefficient of x? A by 1.
1.
So a plus b is equal to minus a. So you'll get 2a. A plus a is 2a. 2a plus b is equal to 0 is one equation. Now, the other thing we know is that the product of the zeros, always you should start with this only. Okay, the other thing you know is the product of the zeros. Product of the zeros is equal to C by A, or the constant term by the coefficient of x square. Now, what's the product of the zeros? The zeros are A and B. So product will be A into B. A into B is equal to constant term B by the coefficient of x square 1. So AB is equal to B. So that means B and B will get cancelled on both the sides, right? B and B will get cancelled on both the sides. So you get A is equal to what, children? What is A?
1.
1, not 0.
Zeros. 0.
0 or 1?
1, ma'am.
1, ma'am.
1, not 0. Okay, it's 1, not 0. Because see here, AB is equal to B. So it's like A is equal to this, B will go for division, B by B. A is equal to B by B, goes for division. So B once. So A is equal to 1, not 0. Okay, now you got A is 1. Now substitute. Somebody's mic is enabled, children. Disable your mic. Substitute A is equal to 1 in equation 1. So what you get? 2 into 1 plus B is equal to 0. So B is equal to minus 2. So we found the values of A and B. So see how the presentation differs. So here we have written sum of the zeros is equal to minus coefficient of x. Presentation is very important. Your teacher, you should impress your teacher, or you should impress the evaluator with your presentation. Steps carry marks in CBSE. So don't miss anything. I'm not writing anything extra. All this is needed by the students. Nothing extra I'm writing. Do the fifth one. Oh, 3x squared plus 7x minus 4. Minus 4. So in question number 5, the sum of the zeros and the product of the zeros are given, not the zeros. Zeros are not given, sum and product. And you have to frame the quadratic polynomial. It's easy, you can understand that. I've taken the LCM.
The fifth question, do we need to write 1/16 before the bracket if it's necessary or?
Okay, fine. So the thing is, I'll tell you, even if you remote, it's fine. Even if you remote, it's fine. I'll tell you why.
Yes.
Okay. Now consider this polynomial x square minus 5x plus 6. Okay, x square minus 5x plus 6. Factorize and find the zeros, children. Factorize and find the zeros. Tell me the zeros alone.
Ma'am, 2 and 3.
2 and 3. That means 2 and 3 satisfy this equation, right? Okay. So was that Rakshita?
Yes, ma'am.
Okay. Who asked this question? Raghavi. Okay, fine. Good. So x is equal to 2, x is equal to 3. Now, 2 and 3 are the zeros. So when you substitute the value in place of x, when you use 2 or 3, what will be the value of this expression? 0. So let's try that. 2 squared minus 5 into 2 plus 6. You must get 0. Only then they are the zeros. So 4 minus 10 plus 6. So 10 minus 10, 0. And what when you use 3? 3 square minus 5 into 3 plus 6. 9 minus 15. Yeah, correct. So 2 and 3. 2 and 3 are the zeros of this quadratic polynomial because in place of x, when we use 2 or 3, the value of the polynomial is 0. The value of the polynomial itself is 0. Now I have written something here. Use the same values 2 and 3 and tell me if the value of this polynomial is 0 for both 2 and 3. Do it in your book. I'm not doing it. You do it and tell me. For this one, when you use x2 or x3, the value of the polynomial should be 0.
No, ma'am. No, ma'am, it's not the 0.
No, I want yes as the answer. Only then I can explain. If it is no, then I'm getting scared.
Yes, ma'am.
For both 2 and 3?
Yes, ma'am.
Yeah. Please try. All of you should get it. You do it. I don't want to do. Now, how did I get from this one? How did I get this? I multiplied this polynomial by 7. I multiplied this polynomial by 7. So x square into 7 is 7x square. Minus 5x into 7 is minus 35x. And plus 6 into 7 is plus 42. I multiplied this polynomial by 7. And what do you see? 2 and 3 are the zeros of this polynomial. But when we used it here also the value of 7x square minus 35x plus 42 is 0 for both 2 and 3. That means when you have a polynomial and you multiply that by any non-zero real number, if you multiply by 0, then you know what happens. So when you multiply the quadratic polynomial by any number other than 0, any number, rational, irrational, meaning anything, any real value, the zeros will not change. The zeros will not change. X square minus 5x plus 6 is a polynomial, okay, whose zeros are 2 and 3. Now multiply x square minus 5x plus 6 by any non-zero real number, okay, and use the same values for x there also, 2 and 3. The value of that polynomial also will be 0. The value of that polynomial also will be 0. This means this is the, you can say that this is the required quadratic polynomial because this one and that into 1 by 16, both will have the same zeros. See, this is that constant, non-zero constant. This is that non-zero constant, like how I multiplied this polynomial by 7. Here, this polynomial is multiplied by 1 by 16. 1 by 16. So if 21 by 8 and 5 by 16 are the sum and product of this polynomial, they'll be the product of this sum and product of the whole thing also. See, you can have 1 by 16 or remove it. Both will be fine. Because I told you that whatever are the zeros of this polynomial, when you multiply this polynomial by anything other than 0, and you get a new polynomial, The same zeros will be applicable here also. You will not get different zeros, same zeros. So here, what do you see? There's a polynomial here. It's multiplied by 1 by 16. So whether you have, so it's like you're multiplying that by something, some real value which is not 0. So this whole thing, whatever zeros it has, the same thing this will have. That is without 1 by 16. Without this. Whatever are the zeros of this one, what you see here of this one, the same will be the zeros of this one also. Because this polynomial is just multiplied by 1 by 16. This polynomial is just multiplied by 1 by 16. A constant 1 by 16. So whatever are the zeros, and the sum product of the zeros for this, the same will be for this one also, 1 by 16 into this. So you can have it or you can remove it. That's fine. You can, next step, you can just write that is equal to required quadratic polynomial. So that again depends on your teacher. Is equal to, you can just remove that 1 by 16 and write 16x squared minus 42x plus 5. Sometimes in objectives, if this option is given, select this one. Supposing this option is not given and this one is given, you can select this. That constant can be removed. You can have it also. You can also remove it. So you can say the required quadratic polynomial is 1 by 16 into 16x squared minus 42x plus 5. Or you can say simply 16x squared minus 42x plus 5. Both are correct. Finished writing, children? The fifth one?
Yes, ma'am.
Okay. Now in 6, m and n are the zeros. See, normally alpha and beta are the zeros. So there, in this question, A and B were the zeros. There, m and n are the zeros. So that means sum of the zeros is m plus n. Instead of alpha plus beta, it will be m plus n. And the product of the zeros will be mn. Instead of alpha beta, it will be mn. Now, what is it there? If m and n are the zeros, find the value of m by n plus n by m. Okay. So f of x is given to be 3x squared plus 11x minus 4. All right. So always, what do you do? Always, you should bring out the values of a, b, c, and then find the sum of the zeros and the product of the zeros. So what's the value of a? A is 3, b is 11, c is minus 4. Now sum of the zeros, not alpha plus beta, m plus n is minus b by a, minus b by a. So if you want, you can write this. Sum of the zeros. Sum of the zeros is equal to minus b by a. That means m plus n, because m and n are the zeros, is equal to minus b by a. Then product of the zeros. Product of the zeros is equal to c by a. That is m into n. mn is equal to c by a minus 4 by 3. Minus 4 by 3. Again, I'll tell you 2 ways of doing this, children. I'll tell you 2 ways of doing it. Again, recommended is this method. Okay. Now we have to find, we have to find m by n plus n by m, correct? So what is now m by n plus n by n? I told you this is the preparation. Always you should do this. That's the preparation. Whenever you have a quadratic polynomial, write the values of a, b, c, write the sum of the zeros and the product of the zeros. So this is like you keep it handy. You will need it. Now, what should you find? M by n plus n by m. How do you do this? Common denominator mn. So you'll get m square plus n square in the numerator. So continue here. So m by n plus n by m is equal to, okay, I'll just do it here itself. Okay, I'll remove from here. Okay, is equal to m square plus n square. That step only, I'm writing it here. Children, just a minute, I'm getting a call. Just a minute. Yeah, thank you, children. So now the numerator m square plus n square. Remember, go back by two sums. A square plus b square is a plus b the whole square minus 2ab. M square plus n square is m plus n the whole square minus 2mn. Minus 2mn by mn. Now, why are we doing this? See, we know the value of m plus n and mn. So we'll write everything in terms of m plus n and mn. Because we don't know m square plus n square. We have only two values. We know the value of m plus n and we know the value of mn. So what we'll do in every situation, if possible, we'll try to write that using m plus n and mn. So here numerator is m squared plus n square. We don't know what to do with that. But you know m squared plus n square is m plus n the whole square minus 2mn. Now how is this useful? M plus n. You know the value. Mn, you know the value. So we always write other expressions using m plus n. That is in terms of m plus n and mn. Is that clear, children?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
Yeah. Now substitute. What is m plus n? Minus 11 by 3, the whole square. Minus 2mn. 2 into, what's that? Minus 4 by 3. Divided by minus 4 by 3. So this will be minus into minus plus 121 by 9. Minus into minus plus 8 by 3. Okay, this one, see, I like to do it like this. Divided by minus 4 by 3. Divided by minus 4 by 3. I hope you all agree with me. Then in the next step, then in the next step, LCM, which is 9. So you get 121 plus 24 into minus 3 by 4. Into minus 3 by 4. So this is equal to versus 146. 146 by 9 into minus 3 by 4. I think you can simplify this and tell me. 145, sorry, not 146, 145. I'm very bad at adding, subtracting. I don't feel shy to say that, but seriously, I go wrong everywhere. 145 by 9 into minus 3 by 4. Tell me the answer, children, after simplifying.
Ma'am, minus 145 by 12.
Minus 145 by. Oh, yeah. It's
12.
Ma'am, I
correct.
got the final answer as 12.1.
No, you can leave it as a fraction. Minus 145 by 12. Correct. Correct. Next one. Oh, but I told you we'll do it in a different way, no? You will all like this method because it will be slightly easier. So you may like this. So what we have understood is whenever we have a quadratic polynomial, we'll find the values of A, B, C, and we'll find the sum of the zeros and the product of the zeros. Normally, alpha and beta are the zeros. Sometimes different zeros are given. So instead of alpha plus beta, you must write m plus n. Instead of alpha beta, you must write mn because they are the zeros. Let me know if you finish writing, children. I'll tell you the next method.
Completed, ma'am.
Okay. Now, is it over, all of you?
Just a minute.
Okay. See, I had divided by minus 4 by 3. So I got it as a numerator like this here, divided by minus 4 by 3. Then division becomes multiplication, minus 3 by 4, reciprocal. Okay, the alternate method is, all of you should write the alternate method also. Please don't write one of the two methods. Whatever you see on the screen must be in your book. So the alternate method is, you can take up the polynomial and try to factorize it. Okay, so what's a polynomial? 3x squared minus 11x, sorry, plus 11x minus 4. Try to factorize this and tell me the two values of x.
And is it 12 and minus 1?
12 and minus 1. Perfect. Yes, 12 and minus 1. So that means what, children? M is equal to, because x is minus 4, x is 1 by 3. They're the zeros. But what are the zeros called here? M and n, right? M and n. So m is equal to minus 4. N is equal to 1 by 3. Or you can take it the other way also. Anybody is m, n. So now what do they want you to find? Sorry. M by n plus n by m. So just substitute the values. M minus 4 by divided by n plus n divided by, see, I've written it using the symbol like this. M by n. M is minus 4 divided by n 1 by 3 plus n 1 by 3 divided by m divided by minus 4. So what do you get? Minus 4, division becomes multiplication, and 1 by 3 becomes 3 by 1, which is 3, plus here 1 by 3, division becomes multiplication, and minus 4 becomes minus 1 by 4. I'll continue here. So that's equal to minus 12. Minus into plus minus, you understand? 1 by 12. Because 3 4s are 12. Now minus 144. Minus 1 whole by 12, which is minus 145 by 12. So you can also find the zero. So then this is not needed. Then all this is not needed. Because you're directly finding the zeros, m and n. Then you don't need to write all this. See, by mistake, if you start like this also, no harm. No harm. After writing, when you're not using it, strike it off. That's all. So this method is finding the zeros directly. You find the zeros directly. You split the middle term, you find the values of x, and they are the values of m and n, because they are m and n only are the zeros of this polynomial. Is it understood, children?
Yes, ma'am.
Okay. Can I clear the screen, children?
Yes,
ma'am.
I don't remember the question number. What is it? 7, no?
Yes, ma'am.
Okay. Children, I'll just come back. Please complete these two answers. Okay, children. So whenever the zeros are given to be the reciprocals of one another or the negatives, okay, the negative of one another. 1 0 is the negative of the other, or 1 0 is the reciprocal of the other. So in that case, we assume like this. In that case, we assume like this. Let 1 0 be alpha. The zeros are negatives of one another. That is, 1 0 is the negative of the other. So if 1 0 is alpha, the other one is minus alpha. If they're the reciprocals of one another, if 1 0 is alpha, the other one is 1 by alpha. Reciprocal, 1 by alpha. So instead of alpha and beta, you must assume alpha and minus alpha or alpha and 1 by alpha according to the situation. According to the situation. Am I audible, children?
Yes, ma'am.
So you must take alpha and minus alpha. If 1 0 is the negative of the other, you must take alpha and 1 by alpha if 1 0 is the reciprocal of the other. If 1 0 is the negative of the other, then alpha and minus alpha. If you can even take beta and 1 minus beta, anything. Just call, you can take x and 1 by x also for that matter. But don't take x because the polynomial is an x, I'm sorry. So you can take a and you can take a and 1 by a, anything. So in general sense, it is alpha. So alpha and minus alpha or alpha and 1 by alpha as the case may be. So in the first one, negative. So 1 0 is alpha, so the other one is minus alpha. So when they're the negatives of one another, use the rule sum is 0 because alpha minus alpha is 0, right? So when you find the sum of the zeros, what is the sum of the zeros? When in this case, you go with sum of the zeros. So sum of the zeros is minus b by a. That means alpha plus minus alpha is minus b by a. So this one is 0. So like that, you can find the value of k. K square is 0, so k is equal to 0. If one is a reciprocal of the other, then go for product. Don't go for sum. Go for product. Product of the zeros is c by a. Alpha into 1 by alpha is c by a. Then alpha and alpha will cancel and you get 1 is equal to c by a. So the required condition is a is equal to c. A should be equal to c. If a is 5, c also should be 5. That's the required condition. That is a required condition. All right, children. Negatives.
Yes, ma'am.
Yeah. If you're using alpha and minus alpha, go with sum of the zeros. Alpha and 1 by alpha, go with product of the zeros. That only will give you the answer. Because when it is alpha and minus alpha, sum of the zeros will be 0. And when it is alpha and 1 by alpha, the product will be 1. Okay. Fine. One minute, let me write it more neatly. 1 second. Write down the question, we'll do it together. Done writing, children?
Yes, ma'am.
Yeah, so again, you can do it in two ways. You can do it like this, say f of x is equal to 2x squared minus 5x minus 3. Find the zeros, children. Sum is minus 5. Product is minus 6. What are the required numbers?
Ma'am, is it 6 and minus 1?
6 and minus 1. No.
Minus 6 and 1.
-3 minus 2.
Minus 3 minus 2 will be plus 6. Product will be plus 6. So project, tell me again, what are the required numbers?
Minus 6 and 1.
Minus 6 and 1. Okay, so now factorize 2x squared minus 5x. Oh, Done writing, children?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes.
So let's read and understand the question better. There are two polynomials given to us, p of x and f of x. It's given that the zeros of, we know that every quadratic polynomial can have a maximum of 2 zeros. There are two quadratic polynomials given, and it's given that the zeros of p of x, the zeros of p of x, they are double in value to that of the zeros of f of x. Now you can see that for p of x, you cannot find the zeros because x squared plus px plus q, you don't have any number there. Numerical coefficients you don't see there. But if you look at f of x, it is 2x squared minus 5x minus 3. So it's possible to split the middle term here and find the zeros of f of x. Because it's 2x squared minus 5x minus 3. We can split the middle term and find its factors. And we found the factors, and hence we found the zeros. The zeros are 3 and minus 2. Now what is given in the question? If 3 and minus 1 by 2 are the zeros of f of x, then for p of x, it will be double that. So it will be double of it, meaning 3 into 2, 6, and minus 1 by 2 into 2 minus 1. That's what is given there. The zeros of p of x are double. So we found the zeros of f of x. We doubled it to get the zeros of p of x. Now we know the zeros of p of x. With the help of the zeros, we can find the values of p and q. So I hope you understood till here. After this, clearly the zeros of p of x are double it, 2 into 3, 6, and minus 1 by 2 into 2, double it. Double meaning multiply by 2. So 2 and 2 will get cancelled, so minus 1. Now take up the polynomial p of x is equal to x squared plus px plus q. Why? Because we'll have to find the values of p and q. What is the sum of the zeros? We know the zeros already, no? We know the zeros are 6 and minus 1. So what is the sum of the zeros? 6 plus minus 1. That is 5. But what is that equal to? Minus b by a. Minus b by a. So that is minus p by 1. Sum of the zeros is minus b by a. That is minus p by 1 is equal to 5. So on cross multiplying, you get p is equal to minus 5. Next, so we found the value of p. We got the value of p. We'll have to now find the value of q. So the next one, product of the zeros is, we know the zeros. The zeros are 6 and minus 1. So what will be the product? 6 into minus 1, minus 6. But that is equal to c by a, q by 1. So q by 1 is equal to minus 6 on cross multiplying. See, children, product of the zeros is 6 into minus 1. But what is the product equal to? 6 by a, sorry, c by a. So q by 1 is equal to minus 6. So q is equal to, on cross multiplying, minus 6. Is it understood, children? It's very easy, right?
Yes, ma'am.
Yeah. No, I'm now thinking, should I again do the alternate method? Okay, alternate method. Should I do it, children? Are you ready for that? Be very honest, or we'll go to the next one.
Ma'am, we'll do the alternate method.
Okay.
We'll do it.
Oh, sure. So the alternate method is without finding the zeros. This one is we find the zeros. That is without finding the zeros. Class, use the emoji. Raise your hand. Shri Krishni, Madhumita, Ritika, Raja, Raghavi, Sashank, Danya, Arjun, Jayant, Rakshita, Dileepan, Krishita, Sri Ranjan, Prajit, and Florentina. Somebody is missing again today. Ritika, you were not there in the last class, right, Ritika?
Ma'am, last 10 minutes I was not there, ma'am.
Oh, okay. Did I share the recording?
Yes, ma'am, I got it.
Okay. Okay, very good. All right, children. So now we'll not find, we'll not factorize and find the zeros of f of x. Okay, so what we're going to do here is take up f of x. You can write along with me. I think you will be able to understand. Finish writing and let me know.
Completed.
Yeah. So here we are not finding the zeros. So we first take up f of x and let alpha and beta be the zeros of f of x. So as usual, we'll use the relationship, the relationships between the zeros and the coefficients. So alpha plus beta is minus b by a, which is 5 by 2, and alpha beta is c by a, which is minus 3 by 2. Now we have done nothing more you can do with this. So let's go to the other one now. Now what will be the zeros of p of x? It's double that of f of x. So clearly 2 alpha, double it, 2 into alpha and 2 into beta. Clearly 2 alpha and 2 beta are the zeros of p of x, which is x squared plus px plus q. So again find the same thing, sum of the zeros. Again find the same thing, sum of the zeros. What is sum of the zeros? Here the zeros are 2 alpha and 2 beta. The zeros are 2 alpha and 2 beta. So what will be the sum of the zeros? 2 alpha plus 2 beta. Because the zeros are 2 alpha and 2 beta, their sum will be 2 alpha plus 2 beta. And that's always equal to minus b by a. So that is minus p by 1. So you can see that 2 is common. And then alpha plus beta, you can substitute 5 by 2. And on simplifying that, we get p is equal to minus 5. In the same way, product of the zeros. The zeros are 2 alpha and 2 beta. Product 2 alpha into 2 beta is c by a. So like that, alpha beta is there, minus 3 by 2. So like that, we find q is equal to minus 6. Q is equal to minus 6. Just a minute, children. Is it clear, children?
Yes, ma'am.
Now, okay, very good, very good. Now, children, let me know. See, I think this is the second session of polynomials, right? Yeah, today's second session. How many of you here have missed the first session, or even if you missed it, have not seen the recording? Please tell me that. Madhumita, I'll ask you one by one. Session 1 attended? What happened? Ritika?
Ma'am?
You didn't attend session
Ma'am,
1, meaning the last few minutes,
Yes,
but
ma'am.
you got the contents, right?
Yes, ma'am, I saw.
Okay,
Ma'am, I
Rakshita,
haven't watched it yet, but I will watch it by tomorrow, ma'am.
you didn't take up session 1 at all, is it?
Yes, ma'am. I was
Okay.
absent.
Okay, Rakshita, session 1?
Yes, ma'am, I've attended.
Shri Ranjan, you had some network issue or something. Your mom said that you were in the meeting till 8:30, and since I didn't, you were not able to join. I don't know that you didn't take up the class, right? Last class, session 1. Shri Ranjan. Okay, see, you're supposed to watch the video because session 1, the introduction given in session 1 is very important to understand today's session. So please watch the recording. If you missed the class, please watch the recording. That's very important. What about Arjun?
Ma'am, I attended, ma'am.
Danya?
Attended,
Session
ma'am.
1. Florentina, session 1. Attended? Florentina?
Yes, ma'am, I attended, ma'am.
Giant?
Yes, ma'am.
Krishita?
Yes,
Session 1.
Yes.
Rajit? Very good. Fully,
At-
Krishita? Fully?
Yes, ma'am.
Okay. Prajit?
Yes, ma'am, I was there.
Okay. Sashank?
Ma'am, I had attended half, ma'am. I'll see
Oh,
the
yeah.
half by today.
Correct. Oh, you have not watched the video fully, is it?
Yes, ma'am. I'll watch it by today.
Okay. Raja? First session?
I attended.
Raghavi?
Yes.
Rakshita? I think I already asked you. Rakshita? I think I already
Yes,
asked
ma'am.
you. Yeah. Dileepan?
Attended,
Session
ma'am.
1. Okay. And Shri Krishmi? Oh, very good. I saw your message. All right. Very good. Is this method understood, children?
Yes, ma'am.
Yes, ma'am.
Okay. Fine. Over to the next one. Somebody's mic is enabled. Please disable your mic. Okay, let's do the 10th one. So it's given that -1 is a 0. If it's a 0, the value of the polynomial itself will be 0. If -1 is a 0, the value of the polynomial will be 0. So -1 is a 0 of P of X. It's given. This means in P of X, that is in place of X, if you use -1, the value of the polynomial will be 0. In place of X, P of X, no? P of X. But what is a 0? X is equal to -1. -1 is a 0 means X is one of the values of X is -1. -1 is a 0. That means X will have two values, right? X will have two values. X is equal to something, X is equal to something. So one of the zeros is -1. So in P of X, in place of X, if you use -1, the value of the polynomial will be 0. That's why it's called a 0 of the polynomial. So how will you work P of -1? In the polynomial P of X, wherever there is X, you should use -1. So K into -1 the whole square -4 into -1 plus K is equal to 0. So -1 the whole square is 1. So K plus 4 plus K is equal to 0. 2K is equal to -4. K is equal to -2. Finish the 9th one, children. Oh, 10th one, sorry, the 10th one.
Yes,
Yes, ma'am.
Okay. Anybody still writing the answer? Should I wait? Okay. I'm continuing. You can see the 11th one. I'm continuing. Okay. So in the 11th one, again, you're given a polynomial. So when you're given a polynomial, immediately you will find the values of alpha plus beta and alpha beta. Now, what are you expected to do? You should frame another quadratic polynomial whose zeros are 3 alpha and 3 beta. For this polynomial, for f of x, the zeros are alpha and beta. For f of x, the zeros are alpha and beta. You should frame a different polynomial whose zeros are 3 alpha and 3 beta. Okay, so you know, this is how we start. All right. Now, the required polynomial. For the required polynomial, the sum is 3 alpha plus 3 beta, and the product is 3 alpha into 3 beta. Required quadratic polynomial is equal to x squared minus sum of the zeros. Now, how do you construct a polynomial? Minus sum of the zeros into x plus product. So this is equal to x squared minus, what's the sum of the zeros? 3 alpha plus 3 beta. correct? Or I'll do one thing, I'll find the value separately for you and then we can substitute. That'll be easier. We'll find the required sum and the required product. The required sum of the zeros is equal to 3 alpha plus 3 beta. That is 3 into
3 into alpha plus beta.
Correct. So 3 into 3 by 2, which is 9 by 2. Then required product of the zeros. The zeros are 3 alpha and 3 beta. Product will be 9 alpha beta. And alpha beta is 1 by 2. So 9 by 2. So the required quadratic polynomial is equal to x squared minus sx plus p. That is x squared minus 9 by 2x plus product 9 by 2. So I'll tell you another method, children. Now what, instead of taking the LCM, what else you can do is, in order to get rid of the denominator, you can multiply this by 2. You can multiply this by 2. Because we know that when you multiply a quadratic polynomial by any real number other than 0, the zeros will be the same. The zeros will be the same, 3 alpha and 3 beta. So actually for this question, there is no one answer. There are so many answers. There is no one answer for this. Because we know that when we have a quadratic polynomial with zeros, 3 alpha and 3 beta, you can multiply that quadratic polynomial by any other real number, not 0, any other real number. That quadratic polynomial also will have the same zeros, 3 alpha and 3 beta. So what we'll do, this is the quadratic polynomial. We know that we can multiply it by any number. So we'll multiply by 2. When you multiply by 2, what will you get? 2 into x square is 2x square. 9 by 2 into 2 will be 2 and 2 will get cancelled. So you'll get minus 9x. And then again, the constant 9 by 2 into 2, you will get plus 9. You can write it like this also. Or you can take the LCM and write 1 by 2 outside. See, or what you can do is you can take the LCM, this one. Or what you can do, when you take the LCM, you'll get 2x squared minus 9x plus 9. And you can write it as 1 by 2 into 2x squared plus 9x. Like this also you can write. Both are correct. You can take the LCM and keep that 1 by 2 outside. Or you can multiply by 2 throughout and write it as 2x squared minus 9x plus 9. Both are correct. It depends how your teacher teaches you. You follow whatever your teacher says in school. Both are fine. Am I clear, children?
Yes, ma'am.
Okay. Please write down. One more sum and we'll wind up the session for today.
Ma'am, we can also leave it as 2x squared minus 9x plus 9, no ma'am?
Yeah, yes.
Okay, ma'am.
It's not a continuation, children, or I said. It's not, okay, 1 minute, good, you asked me. See here, it's not a continuation, it's or. Okay, sorry, see here. This is the answer, or I'll do it again. This ends here. This one ends here, it's over. Please correct your answer if I was not clear, like if I confused you. This is the answer. Please see the screen now. We multiplied this one by 2. We multiplied this by 2. And we got 2x square minus 9x plus 9. That's all. Or what you can do is listen to this, or after this one, instead of multiplying by 2, after this, what you can do is you can take the LCM. You can take the LCM. What's the LCM? 2. So you will get 2x square minus 9x plus 9. Now in the next step, you can take up 1 by 2 outside and write it as 2x square minus 9x plus 9 like this. These are two different things. You can take the LCM and leave it like this, or the volume of 1. So in this question, we are given a quadratic polynomial, and okay, whose zeros are alpha and beta. We are given a quadratic polynomial whose zeros are alpha and beta, and we are asked to construct a quadratic polynomial whose zeros are 3 alpha and 3 beta. So first, with the given polynomial, we find alpha plus beta and alpha beta. Then we find the required sum of the zeros, because what is the required sum of the zeros? The zeros are 3 alpha and 3 beta. So the new sum, the required sum is 3 alpha plus 3 beta, the sum of the zeros. Product is 3 alpha into 3 beta. Once you get these values, put it in the standard form. X square minus sum of the zeros into x plus product. That's a standard form. Next one. All right. So if again alpha and beta are the zeros of this polynomial f of x, you need to construct another polynomial whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. So children, what are the zeros of f of x? Children, answer my questions. What are the zeros of f of x? What is given? What are the zeros of f of x given?
Alpha and beta.
Alpha and beta. So what is alpha plus beta equal to? Minus.
Minus
B by
a
A.
And what is that? Minus.
minus of minus 5 by 2.
By 2. And that's equal to 5 by 2.
5 by 2.
What's the product of the zeros?
C by A.
And that is
7 by 2.
7 by 2. Now, with the given quadratic polynomial, this is all we can do. Now we'll find the required sum of the zeros. Or you can just write required sum, anything. What is it? What are the zeros? 2 alpha plus 3 beta This is 1 0 and the other 0 is 3 alpha plus 2 beta. This is the required sum. These are the zeros of that polynomial which you have to find. So find the sum of the zeros. So this will give you 5 alpha plus 5 beta. On taking 5 common, you get alpha plus beta. And what is the value of alpha plus beta? 5 by 2. So 5 into 5 by 2. So that is 25 by 2. This is the required sum. Now next you should find the required product. Required product of the zeros. Product of the zeros. So that will be, I think I'll take the next slide, children. It will not be convenient here. Finish it till here.
Finish writing, ma'am.
Yeah. So the required product is equal to, what is the zeros? 2 alpha plus 3 beta, 3 alpha plus 2 beta. So 2 alpha into 3 alpha plus 2 beta plus 3 beta into 3 alpha plus 2 beta. This is how we multiply. So it will be 6 alpha squared plus 4 alpha beta plus 9 alpha beta plus 6 beta squared. So you get 6 alpha squared plus 13 alpha beta plus 6 beta squared. So you can write this as 6 alpha squared plus 12 alpha beta plus alpha beta plus 6 beta squared. And you can take 6 alpha squared plus 12 alpha beta plus 6 beta squared. What is alpha plus beta the whole square? Oh, 5 by 2 and 7 by 2. Sorry. 5 by 2 and 7 by 2. So I've written 13 alpha beta as 12 alpha beta plus alpha beta. Because when you then group 6 alpha square plus 12 alpha beta and 6 beta square, you can take out 6 common. And you get something like a square plus 2ab plus b square, which is a plus b the whole square. So now you can substitute the values. We have understood this earlier, that we always want everything in terms of alpha plus beta and alpha beta. So what's the value, children? Simplify. 2 3s are 2s are. So 75 by 2 plus 7 by 2. 75 by 2 plus 7 by 2. So 84 by 2, which is 41. So on simplifying, you get product is 41. 75 by 2 plus 7 by 2. 41.
Was it in 42?
Oh, yeah, it is 42 children, 42. No, it is, oh my God, my addition is wrong. My addition is wrong. 75 plus 7 is 82, right? $75 plus 7 is 82 by 2, 41.
Yes, ma'am.
Yeah.
Ma'am, I got 82 first and then I got confused after you wrote 84, ma'am.
Okay, I'm sorry. So now we have the required sum of the zeros and the product of the zeros. So now we just have to use the standard form and fill the values there. So required quadratic polynomial is equal to x squared minus sum of the zeros into x plus product. So that is x squared minus, what is the sum we got? 25 by 2. Those who have not finished can take a screenshot, or if you think you need to check again, you can take a screenshot. Okay, 25 by 2. This one also you can take a picture. Okay, so 25 by 2 into x plus product 41. We just got product of the zeros 41. So that is, again, you can multiply. See, you have two ways. Either you can take the LCM. So see, after the step, you can do it in two ways. After the step, you can proceed in two ways. Okay. One way is you can multiply this one by 2. So you will get 2x squared minus 25x plus 82. Just multiply that by 2 throughout and this is the answer. Otherwise, you can take the LCM. 2 is the LCM. So you get 2x squared minus 25x plus 82. And then you should take out that half outside. Half outside and write it as 2x squared minus 25x plus 82. Both are correct. Any one you do. Don't do both. Do any one. This one is by multiplying by 2. This one is by multiplying by 2. 2x squared minus 25x plus 82. Otherwise, you can take the LCM. 2 is the LCM. Excuse me. 2 is the LCM and yeah. Then you can take out that 1 by 2. Fine, children?
Yes, ma'am.
All right. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Good night.
Good night.